Yeah. Yes. Are you guys hearing me online?
Yes, sir.
Yes, sir.
So we are going to, yes. Can we
Yes, sir.
take our seats, please? May we take our seats? I don't think I have a problem with the ones in class. Yes. I'm in class now, thank you. Yes. All right, so we are continuing from where we actually ended. So we are continuing with this, okay? So you have to multiply that with that, it gives you -3 what? -3x, and then with that again, which will give you what? -6 less than what? 33, okay? So this will be -3x less than, you take this one to be on the other side, and it will be 33. Because it's negative, it will be plus what? Plus 6, okay? And that will be -3x less than what? 39, isn't it? Okay, so when you are dividing an inequality by a negative number, the inequality changes the sign, okay? So you cannot even divide here because this sign needs to change the direction, okay? So the direction has to change. Therefore, -3x will be greater than what? Greater than 39. So you are going to divide with -3 there, okay? So what are you getting? You are getting 13, okay? So in this case, now when you look down there, you are going to combine them. Are we together? Yes. Come again? Yes, -13, no? It's -13 here. Okay, because of this -3, right? Yes. No, when you multiply by positive, it does not. When you divide by negative or multiply by negative, the sign, the direction of the inequality changes. So we need to combine those ones. So therefore, with between -7 and -13, which one is smaller? Which one is smaller? It's actually -13, okay? So and therefore, -13 is less than what? X less than -7. That is the answer. Okay, so you just need to combine those two. But I do not believe if you are going to be penalized if you actually give this as your solution and basically what? And that. But all you need to do is to combine the two by the greatest and the smallest. Yes. Okay. These ones we have done them, a number of them. Look on the board. We have done a number of them. Yes, this one we have not done it. Okay. Simultaneous equation. One quadratic, one linear is done by substitution. Are we together? So you are going to substitute the linear one into the quadratic one. Okay. So if you are having your graph like this, your x and your y, and you have a graph of what? One of them, one of your graph is actually what? Is a quadratic, okay? So one of them is quadratic like that, and then you have another one, which is what? You have another one which is linear. Remember the first one, which is linear. So the linear one is like that. So how many solutions are these two graphs going to have? They are going to have how many solutions? They are going to have 4 solutions altogether. So yes, so x and y. So there is 2 solutions already there. Okay, right here, right here. And another one is going to be here. These are the solutions. So x and another y there. Are we together? So you need two solutions for x and two solutions for y. Okay? So maybe when you look down there, they are even one. But here there are two. Are we together? There are two solutions there. What I think they are going to be repeated, but they should be four. Okay? Yes. Are you guys online hearing me? Okay. So when you are solving that one, this y class, this is your equation 1 for the linear one. I don't think this color is fine. Maybe yes. So this is your equation 2. Now your linear equation, you put it where you put it in your quadratic equation. Are we together? Yes. Okay. So remember, this is y. This is also y. But what is y? Y is this. You are going to put it there because it's the same thing. Okay. So then, that one will be by substitution. 3x minus 7 equals what? X squared minus 3x plus what? Plus 2. Then, so we need to write this in the form of what? In the form of ax squared plus bx plus c equals what? Equals 0. When you look at this, it's the same thing as what? X squared minus 3x plus 2 equals what? 3x minus 7, isn't it? It's the same thing, right? So I want to move these things on the other side. Ne? So this one will be what? X squared and then minus 3x minus what? When you take this one there, it will be what? Minus 3x. Ne? And then you take this one there, it will be, this is plus 2 plus what? Plus 7. Because it's negative, it will be positive. Equals what? Equals 0. Okay? Yes. Now you simplify, you have x squared minus 6x plus what? Plus 9. Ne? Equals what? 0. Okay? So it's a quadratic equation. You can already have two solutions for what? For x. How do you solve quadratic equations? Factorizing, completing the square and what? And basically the formula. So we are going to do what? We are going to factorize this one. Okay? So we are going to factorize this. Okay? So basically, you multiply this 9 with a 1 here. Are we together? 3 times 8. This 1 times 9, you get what? You get 9, eh? And then, therefore, I will have to find the factor of what? The factor of 9. Are we together? Such that when you add them together, they give you 9. And then when you multiply them together, when you add them together, they give you the middle number. And then when you multiply them together, they give you 9. So that factor is 1 and what? And 9. 3 and 3. Are we together? But the factors, you can also multiply negative 1 and what? And negative 9. It will give you what? It will give you that. Eh? And again, negative 3 times what? Times negative 3 will again give you 9. Are we together? So now you add this together. You are going now to add this together. So I add this. What am I getting? I get 10. I add this 2. I'm getting what? 6. I add this one. I'm getting what? Negative 10. I add this again. Are you guys looking? I'm getting what? I'm getting not 6. Negative 6. Which one is giving you the middle number? Are we together? Yes, sir. So it's actually this. Can you see? Yes, sir. Therefore, this, it means negative 6. Now your variable is x, right? Negative 6 is the same thing as negative 3y and negative 3y there. Can you see that? So I'll take the whole of this and put it here and factorize, ne? Yes. So why is it 1? Come again? Why is it 3y? Okay, so I mean x, ne? It's not y, it's x, ne? Our variable is x, okay? So that one will now be x squared. I'm putting this one there, okay? X squared minus 3x minus 3x plus what? Plus 9 equals 0, eh? So you factorize this by what? By grouping. Now there are 4 terms, okay? What is going on there? Why are you facing each other like this? Look on the board. I'm looking right now at the board. Wonderful. Okay, so now what is common between this is x, ne? So it's x, and then this x squared divided by that, you get what? X. Negative 3x divided by that, you get what? Minus 3, ne? And then what is common in this one? So it's actually 3. But remember the x inside here is positive. Therefore, you need to factorize out negative what? 3. Okay? So minus 3, and then negative 3x divided by that, you get what? X, and then 9 divided by negative 3, you get what? Minus 3 then. Yeah? Yes. So this will be what? X, this one minus that, ne? Minus 3. And then again, the one inside the bracket is what? Is x minus 3. Equals what? Equals 0. All together. So this means that your x minus 3 equals 0. This one, or basically what? Maybe this. X minus 3 equals what? 0. You take the other one on the other side, your x will be what? 3, which is the same thing on this side. That's why they are repeated. In what? It is repeated. Yeah. The way you are going to use this x here, and then you substitute it right here, you get your y. Yes, okay. So now your y is going to be what? It's going to be 3. What is x? Is 3 plus what? I mean minus 7. So this is 9 minus 7, which gives you 2. Okay. So your x is what? 3, and your y is what? Is 2. That's why it is quadratic, but these ones are repeated. Even if you use, but if this was a 4, it means you, yes. Yes, it can be solved by completing the square, factorizing. Completing the square, you've done it yesterday, but I as well wanted to incorporate factorizing there. So yes. Okay, that one we are not going to do it because you are just going to plug in this one on your calculator. Are we together? And then it will maybe be 3 to the 4 equals what? So on to the 4 equals 3, and maybe it will be 4 equals 3. Are we together? So it's going to be something like that. That one, you plug this one on your calculator, press equal, write it into what? Into index notation. So we are not going to do. Yes.
What do you do when you get
What do you do when you?
It's like let's say 3 to the power of 4 times 4 is equal to 3 to the power of 8.
That one you just work out the other side, which is the numbers. You remember, it's the same thing. You are saying 3 to the power of what? Time is not on our side now, and then we have to run 3 to the power of 4 times 4
Equal to 3, 8.
8. 3 to the power of 8. I'm saying it's the same thing like this. You work this one with your calculator. Maybe it's going to be what? Maybe it's going to be 9. It's not even 9, but it's a certain number. So because 3 to the power of 4 times that. If I'm just making a scenario with this, if this is 9 equals 3 to the p, then 9 is the same thing as 3 to the 2 equals what? 3 to the p, and your p will be what? It will be 2.
When you press next set of 9 on the computer, our number what it is to 3 to the power of 4 times 4.
No, it's not going to give you that one. It's not going to give you that one. It will give you a whole number. It will give you a whole number. Okay? It's not, you will not press this on your calculator and you get it back like that again. I'll come attend to your question. Maybe I'm not getting it well. Sequence, we've been looking at it. Let's just go through so that you want us to do that one. But we have looked at sequence already. All right. Okay. So it says that the first 3 terms of an alternative progression. Yes, guys, you're making noise. Remember tomorrow is a paper. that is also going to decide our future. It might not be your favorite subject, but it's going to help you. Know that one, it's going to help you. You need about 25 points. Yes? You need about 3 good symbols for you to go to AS level. So you need to push so that you need to actually to study, okay? So that when one subject doesn't go well, at least 5 are fine. But don't just take out any subject because you don't know how others again are going to be. All right, it says it's basically that. So we should be able to find what? The common difference. The common difference is known as what? Term what? Term 3 minus term 2 should be equals what? Term 2 minus what? Term 1. You don't even need to know that the difference. What is that constant that you are adding up to get the other number? So this one you just take 15. It's not 15, but what? 13 minus what? Minus 15. What are you getting? -2. You are getting -2. Are we together? Are we together, class?
Yes, sir.
Yes. So you are getting -2. So therefore, here you have -2. The nth term of the AP. The nth term is the general formula. Are we together? The general formula for AP is what? Is Cn equals A plus Bn minus 1. That is the nth term of the geometric progression. I mean arithmetic progression. Are we together? What are they saying? The nth term. All you need, you know your first term, you know your common difference, you substitute them there. Okay? So therefore, Cn is going to be what? What is your first term? Your first term is what? Is 15, okay? Is 15 plus, what is your common difference? It's actually -2, isn't it? So it's basically -2. So -2 n minus 1. So you remove the bracket, it will be 15 minus 2n plus 2, isn't this times that you get this, and then this times that it gives you what? That one there, okay? So 15 plus 7 plus 2 is what? 17, isn't it? Yes, therefore your Cn is going to be -2n plus 17. Okay? If you substitute any, when your n is 1, term 1, you put this one will be -2, 1 plus 17. It will give you what? It will give you 15. Are we together? It will give you 15. Okay? So basically, your Cn is just -2n plus 17. Okay? Yes. They are saying find n if the nth term is actually what? Is -183. Are we together? Now you need to find n. They are now saying we know Cn, we know this Cn is that one. Are we together? But now what is this? Is the nth term. Now they are saying that if the nth term is what? Is -180. It means on this Cn, we will say -183 equals what? Okay, so equals a plus what? We are finding n. They are saying Cn, remember the nth term, this is the nth term, this is the nth term. Are we together? Yes. We should use? No, we are starting something. This is something new. Are we together? So just hold on. If they are saying C1 is equal to what? Is equal. If they are saying term 1 is basically what? Is 15. Are we together? Find n. Obviously, our n will be 1. So wherever there is what? Wherever there is Cn here, we will put 15 equals what? A, what is your first term? Is 15, right? Are we together? What is we may use the general formula. we may use the general formula, or basically what? Or just this one here. Okay, it's the same thing, ne? It's the same thing. So this is your first term. Your common difference is what? Your common difference is basically what? -2, right? -2, and then n minus 1. Are we together? Yes, that one is the one you are going to find. Okay, but I wanted to use this one here, the straight one. There. So I will repeat this one again. Okay, so I will repeat this one again. All right, so they are saying find n if the nth term is basically there. If you see this question in the exam, it means you are going to equate. Are we together? Now this is Cn, but they have given you that the nth term, the whole of this Cn is equals to what? To -183. They have given it to you. It's provided to you. Now remember, wherever there is Cn, you just put -183. But what is your Cn? Is right here on the other for the other side. For the other side of the equation, it's actually what? It's equals to -2n plus 17. Numbers on one side, variables on another side, and you find your n. Are we together? Yes. I didn't say it's wrong. No, he said we have to substitute in the one up here. Okay. Sorry for that. So what are you going to do? You move 17 on this side, or maybe the other one. So -183 minus 17 equals -2n. Okay. So what are you getting here when you use your calculator? That one will be -200, isn't it? Equals what? -2n. You divide by that, you divide by what? Negative. You divide by -2, okay? Your n will be what? Your n will be 100. Yeah? Your n will be 100. Yes. Now they are saying if the sum of n terms is -36, determine the number of terms in the AP. Are we together? So we have the formula for the sum, okay? So we have the formula for the sum, which is Sn equals 1. 1/2. I want somebody to confirm for me that formula. Yeah, it's n/2. Yes. And then here you have 2a, isn't it? 2a plus z n minus 1. I just want somebody to confirm that formula for me.
Yes, I do.
I guess, right? Okay. Can you see the same thing? They are saying this one is for the sum. The sum of the nth term is what? Is -36. Are we together? So you are going to put wherever is the sum of the nth term, you put -36 equals what? Your n you do not know. 2. What is your a? 2a. Your a is what? Is 15 plus. Let me just say minus because the common difference is -2, right? Yes. So -2 n minus 1. Okay. So what can I do? I'll multiply this by 2 so that this cancels out, and again on this side by 2, isn't it? Yes. So here I'll have what? I'll basically have 72, right? 72 equals 30. Again, this times that gives you what? But remember, there's an n there. You are not seeing it. There's an n there. This n, this n. Okay? So n. What is happening? Someone's playing. No, it has been doing this since, yeah. So by this one. So this n, and then you say 2 times 15 is what? Is 30. You multiply this will be minus 2n. You multiply this will be what? Will be basically plus 2. Okay. All right. So you carry 72 equals n. 30 plus 2 gives you what? Gives you 32. Ne? So that one will be 32 minus 2n. Okay. Yes. And then what are you going to do next? You multiply inside. Okay. So this one will be 72 equals 32n minus 2n squared. Okay. So what is happening? Write it in the form of ax squared plus bx plus c. It is a quadratic. It is a quadratic. So it's going to be 2n squared. You take this one there again, it will be minus 32n plus 72. It's plus equals to 0. Okay. Then you can use this by what? By using the formula. Then you can use the formula. Yes. 72 did not move. It's still on this side of the equation. Which? No. He's right. Yeah. He's right. We didn't carry this. Can you see this? This negative. He's right. Since from there, we were supposed to put this negative there. Okay? Oh, yes, me. Yes, here it will be now. No, it's actually us. It's us because we are involved. It means that you are not following. You are the ones that are giving me answers like 72. I'm just writing. Yes. All right. So the next thing you can use the formula, but you can still divide by 2 all together. So this one will be n squared and then minus what? The 16 n and then minus what? Minus 30. 36 equals 0. Yes. All right. So basically that one you can use what? You can use the quadratic formula. Grouping is from factorizing. So we used already what? We used already the factorizing. Now we are moving to the formula. So your n will be what? Negative b. What is your b? That is now is negative 16 plus minus square root of what? B squared. What is b? Is negative 16 squared minus 4a. What is your a? Is 1. C. What is your c? Negative 36. Okay. Everything divided by 2a. But what is your a? Is 1. You use your calculator. I want the values of n. Those that are having the fraction calculators, you put the fraction and you just change this, ne? Are we together?
Yes, sir.
Yes. Chance, is everything okay? All right. Yes, you can do anything. But those that are having this type of calculators, you should work out step by step. Are we together? So you need to work out this. Yes, one of them is what? Guys online, I want your answers. Are you guys there?
Yes, sir.
The other one? Negative 2. And negative 2. Your n will never be negative. Therefore, the only correct n is 18. Yes. Trigonometry, we have looked at that one. All these area things, we have spoken about those things. Yes, even this one. All these things, vectors, we have looked at them. All these ones, we have looked at them. Remember the model class name? Yes, for yesterday. That if it's not fixed, like here is different, it's 5, it's 10, it's 5, can you see that? It's 20. So you use the frequency density altogether. So it means you need to make use of your frequency density, which is now to be drawn there. Yes, sir. Logs. We have looked at them for several times. This one. Logs, we have looked at them. A single log and a separate log. So logs, we have looked at them as well. So this one, it will be what? It will be log 2 to the power of y. This one, you know, remember when you are eating, you go stretch your head on logs. Yes, that log. Yes. 1 is equivalent to what? Plus log 10 plus log what? Log 5. Are we together? Yes, it's minus log. It's a minus there. You see, that's why we are together. I like that. Yes. So you can work out this again, separately. So this one will be log 2 to the y minus what? Log 50. Okay? Log 50. Yes, what is next? What is next? The next one you are. Yeah. Remember class. There's something good right here. They are not saying we should express it as a single log altogether, but as a what? But in the form of that. But when you look at that, it's still a what? It's in the form of a single log. That is the way forward altogether. Yeah. Where a is a constant. No, it's fine. It's fine. It's okay. Altogether, it's fine. So our steps were fine. Remember, we had what? We had log 2y minus log 10 plus log what? Plus log 15. This is a single log. Okay? It's a single log. We are fine. Okay? So this is log 2 to the y minus what? Log 50. Because when you add, you multiply this, okay? You multiply those ones, né? Yes. And then when you subtract, you divide altogether. When you subtract, you divide. This will be log 2 to the y divided by what? Divided by 50. Yeah, the factors of 50. Now, I want you guys to write 50 in the index notation. Yes, in the index form. Is 2 to the power of what?
2 times 5 to the power.
Is 2, this is log 2y, then you are adding what?
2 times 5.
2 times 5 to the power of what?
2. Only the 5.
Okay. Okay, to the power of 2. Okay. Are you guys with us online? Are you guys with us online?
Yes, sir.
Yes, sir.
All right. Now, one thing that you should again know is that when you are dividing, you subtract, ne? So here they say 1 day altogether. there's actually a 1 there. So that one would be log 2y minus 1, dividing what? Multiplying, and this is going to be what? That is actually 5. Yes, it is 25. But we are actually dividing. We are actually dividing. So it's not 25 that one. It is 25, but remember, it's something like this. Can you see that? Okay, so we have a law that says a to the negative 10 is actually what? 1 over a. Can you see that? Yes, so we need to transform it. So it's actually the same thing as that. So here is just you are multiplying by what? By 1 over 5 to the 2. Okay, 1, 5 to the 2. Yeah, it's yeah. Guys, I want you to be involved. Be involved, yeah. I want you guys to be involved. Doesn't it come? Which one is this? This one. No, it's the same thing. This is the same thing as multiplying this by what? By 5 to negative what? Negative 2. Yeah, but the only issue here is that this one is not a 2. Otherwise, we could define here. Otherwise, we could define there. So we will have a look at that again. We'll have a look at that. So the only thing, you know, this one can just, if it was a 2, this one can be, yes, this one can, they say when a is just a constant, any number. Okay, so it will just be fine. This is the only focus, okay? That is the only focus. So it could be, if it was a 2, then we are going to add that, and it will be y minus what? Minus 3. And then it's fine. Yeah, so we will have a look at that.
You know what's great? I understand that it's not just to get the y minus 1, but because we still have
yeah, you see, everything from there is fine. Yes, Louis?
Sir,
Yes.
if A can be any number, how is the A positive? Because they say 2A y plus A. Which number is positive?
Why are they saying? May you repeat again?
So how is the constant? Should the constant also be positive?
No, a constant is just a number. It can be negative, it can be positive. They are just saying that we are going to end up with a value. Remember from here, okay? So our A is just a number. A constant is just a number. It can be negative, it can be positive. We have positive numbers and negative numbers. But everything from here is fine. Everything from here is fine. The thing that is holding us up now is right here. Okay, remember from here we have what? We are having log 2y minus 1, right? Because of this. Are we together? Okay, and then what is this? is actually multiplying what? 5 to -2. Okay? So what is holding us up is if this was a 2, then we are done. Are we together? If this was a 2, for example, you are having log. Yes, now it's not a 2. Therefore, I am honestly stuck and I don't know how to attempt it. Yes. It's not that it's unsolvable. It's not that it's unsolvable. But the scenario that I'm giving you is this one. If it was log y, if it was log 2y minus 1, multiply maybe 2 to the -3, like that. This one will be log, this one will be log what? It will be log 2y. When the bases are the same, you only add what? You only add the index, né? So -1 plus -3 is what? -4. Then it's already in this form where a is -4. Only this. Only that one. This 5 here is the one which is giving us problem. Okay. So we will come back again for that. Yes. I'm saying we'll come back out of the. I'm honest to you, I cannot attend to it because you are right until then. Yes.
Now, instead of now saying that log 10 plus log 5, you try the log 2y minus the log 2 of y with 10. Then maybe we can end up with
You are saying?
like we have log 2 of y, right? Minus log 10. So instead of now doing the addition first, why can't we do the multiplication?
Okay. Okay. Yes. Okay, no, it will surely it will be the same thing. So this one will be log 2 to the y divided by log. Not that one will be log 2 to the y divided by what? Divided by 10. That is what you are saying, right? Okay. And then you say what? Plus what? Plus log 5. Now when you add, what do? You multiply. When you add, what do? You actually multiply. So this one will be what? It will be log 2 to the y over 10 multiplying what? Multiplying 5 over 1, okay? Which is the same thing. So this one will be what? Now we are moving from there, okay? This one will just be 5 times what? 2 to the y. Remember there's a log there. 2 to the y over 10. Can you see that?
Now we think of factors of 10,
which is 2 and 5, yes. The factors of 10 is 2 and 5, so therefore this one will be 2y over what? Over 2. You got it? You got it, it's right. Yeah, it's right. It's right. Guys, we are not following and some of you missed out already on that. No, it is like this, man. Yes, sir.
Dwell too much on that one question. It's not going to be the end of the world. You understand? Like if you give the idea that you solve it is fine, because we didn't even look at that graph yet. Yesterday we looked at how to sketch the graph one. Maybe tomorrow's paper will have the grid, like when you have to plot. You understand? So I've seen with some questions that were posted, especially yesterday, that when they have to solve, they say graphically determine your x's, for example, when y is equal, they don't know that concept. And I feel like the graphs, questions that will always be there are simultaneous equations, the completing of the square, the graph will always be there, your cumulative frequency will always be there, whether it's the histogram or whatsoever, and then what else? Those are questions that the paper can't be without those questions. So it's almost like we can predict, and the thing we haven't looked at are graphs. You understand? So let's scroll up to see if we can find a question on graphs.
Okay. So
Yeah, just let me try to shorten
it's
it.
done.
Let me try to shorten it. Just on that on this note. On this note, let's just look at it. Luis raised the hand. Luis, we can do it afterwards. We'll still be here for some time. If it's a log question, yeah, if it's about the log question, we'll just keep it on hold for now. Ne? Luis, are you asking on the log question?
No, sir. It's a completing of the square question.
Okay, we will also look at it. Whilst, guys, listen. Whilst we are talking about, guys, I need your attention. I just want the white thing. I don't know. I hope it's not writing too big. Okay, it doesn't do the situation as the iPad. That one increases your handwriting also. So I just want the blue. I mean, just a white screen. Completing of squares. Yesterday, somebody asked, so that term that you are adding and subtracting, does it matter where you put it? Yes, it matters. Remember yesterday I said, I give you 10 bucks, I take it back, it's as if I give you nothing, right? So how do I take out something that I haven't given you yet? Does that make sense? So you have to be plus first and then you subtract. What I mean with that is, if you are having your ax squared plus your bx plus then your c. So we said that b is your focus, b over 2 squared. That's the term that you add and subtract, right? So we said that we're going to write it as your this plus then you've got your bx, then you add the term, and then you have that, then you subtract the term. You understand? So you can't take away something that I haven't given you yet. That's why it's important to add first before we take away. Yeah? Is that clear? We ensure that the coefficient in front of your x squared variable here is always 1. Are we together? So Luis, maybe whilst we are here, you can ask your question.
Sir, when you're getting the turning point, what helps you identify whether it's a minimum or a maximum?
Okay, very good question. You see, if you look at the structure of your graph, and it's going to bring us back to the graph thing I want to explain that. If you have a quadratic one, right? If you're having something like this, let's maybe do it like this, just a different color. If it has a shape like this or a shape like this, we would say that this is where you have your x is positive, meaning it's more than 0, right? Your x, basically, I just say x, but I mean the x squared. Are we following? And here, your x squared is less than 0. Are we following, guys? Okay. Now, if that is the case, sometimes we say smiley face and so on. Now, look at this, Luis. If you are looking at a maximum or a minimum, it entails the following. Look at the turning point here. If this is your turning point, your graph is going up, it's going up. And if you look at your x and your y coordinates, you'll see that they keep increasing, they keep increasing. Therefore, this will be your minimum because everything else is increasing, they are going up. Are we following? The other one will be your turning point is here, then that's the maximum turning point because all the other points on the graph are going down. Are we following? They are reducing. Is that making sense? Are you seeing that, Luis? So for graphs that have a positive one will have your minimum. Graphs that have a negative one will have your maximum. Hey, guys, just relax, please. Just hold on, just 5 more minutes, okay? All right. Yes. No. We did this yesterday. I think you need to go and watch that video. We did it in the morning. When we were looking at the turning point, once you get to the stage whereby you write it in terms of completing of a square, your P and your Q, the formula for your turning point would be you make your P negative or you change the sign of your P, and this is that. So let's say, for example, you had x minus 12 squared plus 3, for example. Your turning point would be a positive 12 and a 3.
Why is it a positive 12? Because your P value is changing its sign and your Q value remains like this. So this coordinate in terms of X and Y is giving you a turning point. So the reason why we complete the square is to get the turning point. Does it make sense? Okay, so in that question, please go through that where you are sketching there. Okay, guys, you can go. It's not a problem, but I think what I'm trying to show you here is vital. Okay, no, it's fine. It's sharp. See you then. Good luck for tomorrow. Okay, so it's just Maria and Agnes that have gone there. Who else is out? Because we didn't take the attendance. I would like to take the attendance, please.
On that one, sir, just emphasize on the x squared. It's a.
Yeah, the value of a, not
Yes.
the x squared. Yeah, you're actually correct. The value of a, sometimes even if you do not have the a,
The
it
x
means
squared
the
is
a is
correct.
1.
The x
Are we following?
The x squared is correct. It's just that they don't see that
Yes.
a has influence on them.
Pardon? Yeah. I even told Andreas on the online thing. Andreas, I think Andreas has a sleeping problem. Something is wrong there. But anyhow, let's quickly look at this, guys. Okay. So listen, whenever you are dealing with graphs, now they say graphs of functions. So graphs of functions means that, hey, guys, you will have a function. Now, function is your output, which is your y. Are we following? So please get it in your mind that f of x is the same as y, or g of x, whatever they use here, is the same as y. So for example, if I give you something like this, f of x is equal to 2x plus 5. Are we together? I can rewrite this as y is equal to 2x plus 5, which is a straight line. Are we following? So regardless of me putting y or f of x, same thing. It doesn't limit you to f of x. It could also be g of x. Maybe I've got a quarter x minus that. This I can also write as y is equal to a quarter x minus that. These two things are the same. Please get that concept. Because they could give your graph in terms of the function, or they could give it like this. We don't know. Are we following? So please get that. Now, you only need to know 3 graphs to plot. I'm going to show you 4, just as an addition. I don't know whether they'll show you that. So let's say the first graph, we expect you to be able to plot a graph that is a straight line, which is your mx plus c. Are we following? All right. Now, this graph, if it's a straight line, we sometimes just put it as this. So if your x is positive, which we don't write, but I'll just put it to emphasize, and then you've got the c-intercept. It will have a general shape whereby you've got your x and your y-axis. So the y-axis will be cut at a positive 1. Are we following? Somewhere at a positive 1. Are we following? And your gradient is positive. So your graph would look something like this. The reason why we have a positive gradient is that it stretches from what I call the positive zone to the positive zone. How do we get this? We get this by saying your x here is a, what is this? Is a negative value in this quadrant, your second and your third quadrant, isn't it? What about your y? Your y also, actually your third quadrant, your y will also be negative, right? If you're looking at the x and the y, negative times negatives gives me a positive. So that's why I look at it like this. Here I will have a positive and a positive. I multiply, I get a positive. Here I'll have a negative for my x and a positive for my y. The product of that would be negative. Here I have a positive for my x and a negative for my y. The product of that would be negative. Stretching from negative to negative is a negative gradient. One way of memorizing it like that. Otherwise, just look at the shape. Are we following? Okay. So now for straight lines, if you have y is equal to a negative gradient, let's just put a positive constant there. So what will happen with that is you have to stretch from negative to negative. Are we following? So your general shape would look something like this. Why am I here? Because my constant, your y-intercept here is positive. Are we following? If it was y is equal to negative x minus that, my graph would look something like this. My y-intercept has to be a negative value because my y-intercept is negative 8. Are we following? That's the general shape of a straight line. The other way around, when they are positive, then we'll have something like that with the positive. If it was positive, cutting the x-axis here, I mean the y-axis, it will have something like that. Does that make sense?
Okay, I think erasing takes too long, so we can just keep on zooming this. All right, so now the next thing is, so we know now when y, okay, that's the same thing. Y is equal to just x. Be it now positive or a negative x, we know how it goes. The next one now is when you have y is equal to x squared. Are we following? Right? Then you will have a quadratic one. Since your x is positive or your a is positive, rather, you will have it like this. If your y is equal to a negative x squared, then you will have the shape like that. It is helpful to know the general shape before you plot the graph, so that you can see whether you are correct or not. Are we following? All right, then the last one, the last graph is when you have y is equal to some constant over a variable. Are we understanding? So it could have, if I give you an example, it could be something like y is equal to 2 over x. Are we following? The general shape of that graph, if it is positive, will look something like this. Are we following? What gives it away is your table. If your table is having that separation, right? You've got a bunch of values on this side and another bunch of values on that side. This is what he had. If it is negative, if your y is a over a negative x, then the graph would look something like this. Are you following? If it's negative, but you don't need to memorize it. You can do the table and plotting one. Eh? Yes. Pardon? Yeah, in this case, yes. Why do they say where x is strictly greater than 0? What does it mean? Because if you put a 0 here, it will be undefined. You can't divide with a 0. Are we together? So they are just making sure that the function is working. Is that making sense? Okay, now the other thing I wanted to, we're zooming too much. I think we must just get a bit of clear space. Let's see if we can just get, okay, was that clear space there? Nothing, nothing, nothing. Okay, let's go to a graph. Now that we know the three general shapes, I just wanted to add, yeah, look at that. Now, this is the one I wanted to add. I put it there because once you see it, please don't panic, no? But this is from the extended. Remember we said we've got y over a constant there. It could be any number with that. It could be a positive or a negative, right? But look at our y here. It's raised to the power of 2 now. Are we together? Now that general shape looks something like this. Just as an addition, it will have two parts. If it's positive, it looks like that. Are we following? If your y equals to a x squared is positive. If your y equals to negative a x squared, it is just going to be where? At the bottom part like this. Are we following? Of course, that you can go and confirm from the table. So this part of the table is for one side of the graph. Are we together? Since that one is positive, then this one, you see there's negative values with positive values. Your x's are negative. That's why it will be here, because your x's are negative here. Your y's are positive. It's going up like that. Are we following? And then here, all of these are positive. Both the x and the y's are positive. For this part on that side, that's why it's like that. Are you following? Okay, this is what it looks like. Now, after you have plotted the graph, these are the questions that we are looking at. Now they tell you, take that graph where it is unequal to 0. We could put it like this, or we could just say x is just strictly bigger than 0. They want you to plot for the x-axis between the number -3 and 0.5. Are we following? So your x-axis, if you have your x-axis, can only be from -3 up to your 0.5. So most probably your 0 would be here. Are we following? And your x for the other side, because remember you've got two of them. So your x for the other side is now from the 0.5 to the +3. You see how that you should be able to read that language. Are we following? The next one on the same grid, plot this. What is this? That's a straight line. Are we following? With a negative gradient. So most probably it cuts at 3 here, and it goes like this from negative here to negative. It looks like that. Are we following? Okay. And then they tell you that one that you're plotting for the range here, for your x here, not your range, but yeah, domain. But don't worry about that. Your x here stretches from -3 up to 1.5. That's the limit that they're giving you. Now, what happens is they want you to solve this graph. You've got this graph, okay, and this graph, and they want you to solve it simultaneously. Now look at this. If you draw these two graphs, you'll have one here, okay, and you'll probably have that straight line cutting like that. Are we following? So if they want you to solve it simultaneously, since both of them are equal to y, I can equate y to y. This is common for all the problems you're going to solve. So you will say, since y is equal to this 3 over x squared plus 1 will be equal to the negative 2x plus 3. You only have in terms of x, you solve for x there. Are we following? What is going to happen once you say x is equal to 3, for example? Then we put the 3. How are we going to find the y? Take that 3 and go and substitute it in any of the two, right? Put the x here. If it was 3, it would be 3 over 9, because this is squared, right? So 3 over 9 would be 1/3 plus 1. Are we following, guys? All right. Or if you go and put it here, and with the 3 here, it would be negative 6 minus your 3, which would give you negative 3. So the y would be negative 3. When you are faced with this, try to take the simplest one. Why do I want to go in square and deal with fractions and so on? Are we following? So that's how you will solve that. But there's another interesting one I wanted to look at. There's one that will tell you you should solve this by using graphically. Let's see if I find a problem like this. This is a common thing. A lot of learners are struggling with it. Let's see. I hope this will be the last thing we do. Listen, by the way, we gave hard copies to the learners that are here in class. I advise you to please go through these questions. If I can promise you, if you can do all these questions tonight, you'll pass maths tomorrow. Seriously. Because you can even come afterwards. Once we get the paper after 2 days, we can take that paper and take this practice questions, and you'll see. We might find similar questions in the paper itself. Are we together? Luis, you can go ahead whilst I'm looking for the question.
So on the graphs of functions, they sometimes ask you to draw a tangent and then estimate a gradient on the tangent.
Okay, so if you have something like this, you've got a graph like this. Luis is asking serious questions because she's doing past papers, because these are questions from past papers. So they tell you maybe the tangent. They tell you the tangent should be equal to, say, where x is equal to 2. So where x is equal to 2, here 2, you make a point and you draw a tangent. What is a tangent? It must just touch there. Are we following? At just one point. All right. So Luis, if they ask you to estimate, maybe if they do that, they might ask you to get the y value. Then you can read the y value from here. Are we together?
Yes, sir.
Does that make sense? So the tangent
Yes,
would be at that specific point. This is the question that I was looking for, guys. Look here. This is a quadratic graph. Are we together? Which was moved. Are we together? To the -8 side. But let's not worry about that. That you can find after you have drawn the graph. So let's say, for example, your quadratic graph looks something like this. Now they are saying, find the x values when you have this equation. Now remember, this equation is the same as y is equal to x squared minus 8, isn't it? Because, or you could say f of x is equal to x squared minus 8. Now that y, or that f of x, is now replaced with -2, even though it's on the other side. And those are things that we are putting there to confuse you. Are we following? So what does it mean? It means your y is equal to -2. Are we together? They want you to find what are the x values if y is -2. But they want you to do this by using the graph. Are we following? So what is this? This is also a graph, right? It says that the y-axis is cut at -2. So you would go to the y-axis and you go down to -2. What is that? You draw a horizontal line, and then this point, when it cuts the graph, you read off your two x values. This will be your x1, this will be your x2, and those are the two x values that you're going to put in there. Very straightforward. Are we together? Yes. No. Okay. So this is what we have over here. So this is how you can solve it. What if they say where your f of x is equal to 4? It's the same thing as y is equal to 4. This here is a horizontal line. Go to the y-axis, 1, 2, 3, 4, draw a horizontal line where it cuts the graph, read the x values there. Those are your two x values that you put there. Very straightforward, easy 2 marks, no? But it's a question that makes us go, how do I, you understand? Yes.
Now, what if you move everything to one side?
What do you mean?
Is it like move the next?
No, look here. They say use your graph. Use your graph to do it. If you have this is what? This one, what will you have now? X squared is, if you move this over to this side, minus 8 plus 2 is now equal to 0. Are we together? So yes, you can solve this. X squared will be minus 6 is equal to 0, which means that x squared will be 6 square root of both sides. So the x will be equal to plus minus the square root of 6. Are we together? All right, so the square root of 6. So those values, those are the exact values. So you can test like that. The x's that you are getting here are those the square roots of 6 there, for example. But they don't, no, you can't use difference between two squares because 8 is not, the 6 is not a perfect square. Only when it's a perfect square. Are we together? If I had something like x squared minus 64 or x squared minus 4 or something where I have a perfect square, this number has to be a perfect square. Are you following? Okay, so this is now on graph. Now guys, look here. I want you to take a look at this. 2020, you will see that these are the most recent papers. These are 2020 and 2021 papers. So please, guys, go through the papers. It can be helpful if you understand the concept. No? So guys, from now until 10 o'clock tonight, you'll be fine. Yes. Yes, you can always. I'm going to church now from 6 o'clock until maybe 7:30. So from 8 o'clock to 10 o'clock, you can ask any questions. After 10, you'll be sleeping. Okay, so guys, go through the questions online. I'll also share the questions with you. Nobody leave the class, please. Tomorrow we are starting.